Welcome back, and here we are going to talk about section 12.3 on synapses. So first, let's describe what a synapse actually is. It's going to be the place where a neuron connects to another neuron or it could be an effector organ. So I know we don't see the full picture of things, but imagine we have one neuron, and I know my picture is so beautiful. So here's neuron A. And then what we're doing is we're either going to synapse onto neuron B here, or it could be any other effector organ. So maybe it's going to be some skeletal muscle in which we're going to send some neurotransmitters over to. Now there are two types of synapses. We can have an electrical or chemical synapse. Our chemical synapses are going to be far more common than electrical synapses. So we'll mostly talk about the chemical synapses throughout the rest of our lecture, but quickly let's describe a chemical synapse. This is going to be when our presynaptic and postsynaptic neurons are bound together by what's known as gap junctions. So you can see these placed right over here, and it's going to have a fast synapse, meaning there's no synaptic delay in passing this electrical signal. So we're moving straight from one neuron over to another one very easily and quickly because these channels are open, and just let those ions pass through. Now for our chemical synapse, it's quite different. This is our first neuron, neuron A. So the site that we are looking at, and I wish I kept my picture from before, but the site that we're looking at is at those axon terminals, specifically at the synaptic knobs. So this area right here. And we're going to draw in like a dendrite from neuron B here, in which this information is going to pass to. Okay, so here's neuron A, which we are going to call our presynaptic neuron. And then this would be neuron B, in which we're going to talk about the postsynaptic neuron. And of course, the synapse is taking place in between here. So I'll put an S there. Okay, so our presynaptic neuron is the one that is producing the signal. So a nerve impulse or action potential comes through here, and eventually the postsynaptic neuron is going to receive that signal. But we do have to go through some processes in order for this to happen. Now this area that I wrote an S in, I'm actually going to write an SC because this is a space known as the synaptic cleft, and it is a fluid-filled gap between these two neurons. So what will happen is this nerve impulse will come through, and then our neurotransmitters that are contained within the synaptic vesicle will be released from this synaptic terminal through a process known as exocytosis. And now the neurotransmitter, in this case, this neurotransmitter's name is glutamate, is going to diffuse across this cleft and will make it over and bind to these postsynaptic receptors. When the neurotransmitter is binding to these receptors, they help initiate something known as a postsynaptic potential or a graded potential. And again, we'll talk more about what that is in the coming slides. So through this chemical synapse, we experience what's known as a synaptic delay. And that is the time that it's going to take for all of these events to take